Before we jump into chemistry and sustainability, we need to review some of the foundations of science, which involve reviewing math. So we're going to review scientific notation, exponents, powers of 10 with exponents, metric prefixes and setting up conversions with metric prefixes, significant figures and decimal places, and conversions between metric units and English system units that we use in the U.S. This should be an active learning between taking notes as well as doing worksheets on your own and during lecture and doing questions for study review after lecture. You should be able to follow all the math and review everything that we'll be doing for the coming weeks. So this is something that will be around, and so if you need help, be sure to seek it early on in the semester.
Notation is a method used to express number values, and it's most useful for very small numbers like this number 0.000001, or very large numbers like this number. This is 1 with 6 zeros after it. So having 6 zeros or 6 placeholders, those are those zeros, 1, 2, 3, 4, 5, 6 zeros, is instead of having a bunch of zeros that could be lost, this is used as an exponent to say this is a 1 with 6 zeros after it. This is also a number with 6 zeros, but before the 1. So 1, 2, 3, 4, 5, 6 zeros before the 1, or 6 places. And since these are 6 zeros before the 1, including the decimal, this is a negative exponent. So scientific notation takes a number that is in what's called standard notation, which is just the numbers you're used to with zeros before and after, including decimals, and turns it into scientific notation, which makes the number between 1, so more than 1, but less than 10 by incorporating these powers of 10. So it uses a power of 10. This would be 10 to the x, and x is an exponent that allows you to have this is the coefficient multiplied by some power of 10, and which is scientific notation, and allowing for a number that's more than 1 but less than 10. Okay, so when you have a positive exponent, those are zeros or after the ones place. So you can see this is 10 to the 1 means that there's 1 0 after the 1. So here's a 1, and then there's 1 0 after there. 10 squared means that there's 2 zeros or 2 places after the 1. And so 10 to the third means there's 3 zeros or 3 places after the 1. Okay, and so when you have a very large number like this number, 2300000, you want to turn this standard number into an scientific notation by taking this, which is the right next to the decimal is the ones place. So this is right next to the decimal, so 1.0, this would be the ones place. And then move this decimal over until you have a number that is more than 1 and less than 10. So this moves over 1, 2, 3, 4, 5, 6, 7, 8, 9 times to have the number 2.3. And the 9 times that it moved becomes the exponent in the power of 10, 10 to the 9. Okay, so this is very useful for large numbers like this, and it's so that we don't lose any of those zeros. Okay, so for a large number like this, you would first place a decimal if there's not one, and then move it over until you get a number more than 1 less than 10. So 1, 2, 3, 4, 5, 6, 7, 8 places. So this would be the exponent becomes 8, 10 to the 8th, and then that's the 7. Now this is the format for inputting into Canvas quizzes. So that's your Canvas Quizlet, or your Canvas quiz that you take after lecture. So you'll see this in your assignments for today and moving forward. So it's useful to have scientific notation because it's too easy to lose a zero. When you're writing all those 8 zeros, if you accidentally write 7 zeros, well, you're talking about a whole different number. So here's a bunch of zeros, and so you want to start by placing a decimal there if it's not there, and then moving it over until you have a number that's more than 1 and less than 10. So 1, 2, 3, 4, 5, 6 places to get to 2.1. And that was 6 places, so that's represented in the exponent 10 to the 6th. And so the format is using the asterisk, and this is a up caret. Okay, and that indicates that upper exponent. Okay, so when you have a ton of zeros like this, start with, we got to get rid of those zeros by putting it into scientific notation. Put a decimal, move it over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And so this becomes 6.02. Okay, there's still that 0 and 2 there. And those are 23 zeros, so times 10 to the 23rd. And so this is the format that you would input into a Canvas quiz. That's an asterisk with that up caret. The standard notation is also called decimal notation, although you have both scientific notation and decimal notation have a decimal in there. The decimal notation, the decimal can be anywhere in the number. For scientific notation, the decimal always has to be a number that is more than 1 and less than 10. So your number has to be greater than 1, so that number x in scientific notation has to be more than 1 and less than 10. Okay, and so this is the decimal notation 0.1. So this decimal is before the ones place, and so this is indicated with the scientific notation as a negative exponent. So this would be 10 to the minus 1. Okay, so there's a 1 0, this 0 right there, in front of the 1. That would be the ones place. 10 to the minus 2 means that there's 2 zeros in front of the 1, and so this would be 0.01, and that's 10 to the minus 2, when you can always call this 1 times 10 to the minus 2. This is a 1, and you would take this, put a decimal there, and then move it over 2 places. So adding a 0 there and a 0 there is how I got to 0.01. But when you have a negative exponent, those are zeros or places before the ones place. And the negative exponent does not mean it's a negative number. It just means it's a very small number. Usually there's a bunch of zeros, and that's a very small number. It's fractional. It's between 0 and 1. It's less than 1, but more than 0. It's in that fraction decimal area. And so we've got 10 to the minus 1 means that you have 1 0 in front of your 1. And so that's taking a decimal and moving it over there. Or here's a 1 and representing 10 to the minus 2. You start by putting a decimal and then moving it over 1, 2 places. And so having that decimal there means now you've got a 0 in the front. You got to add that, and a 0 that's holding that place. So you always start with a 1. You can add a decimal, and if it's 10 to the minus 3, it means this is a number smaller than 1. Move this so that it is over 1, 2, 3 places. Put a decimal, put zeros in those spots, and then add a 0 in the front. So that's how you end up with the standard notation for those. So this is a small number, is when you have a bunch of zeros in the front. And the people sometimes ask, do I move the decimal left or right? I think it's easier to think of, what is your original standard notation number? Is it a very large number, or is it a very small number? And so a very small number will end up with a negative exponent. A very large number will end up with a positive exponent. Okay, so I'll show you this. Is you have a decimal here, and to turn this into scientific notation, it needs to be more than 1 but less than 10. Move this decimal over 1, 2, 3, 4, 5, 6, 7 to get to 1.2. because the original number value was a very small number, that means it's going to be a negative exponent. So that's -7 for the 7 places. So useful for very small numbers, putting a decimal here. This is another example. Here's a decimal with a bunch of zeros in the front. So you want it to be a number more than 1, less than 10. And this is moving this decimal over 1, 2, 3, 4, 5, 6, 7, 8 to end up with 7. And that was 8 places, but it started off a very small number, so 10 to the -8. Now this showing an asterisk and a caret, so this is an asterisk and a caret. This is the format for entering an answer in Canvas quizzes. And so Canvas is how you're going to be taking quizzes, both the Quizlet that's after a lecture, or quizzes and midterm and final for Chem 9. So this is another example. This next one is 0.00021. So we want it to be a number more than 1, less than 10. So take the decimal and move it over 1, 2, 3, 4 until you have 2.1. Because the original number was a small number, it's a -4. Okay, so this would be, if you're entering this in Canvas, you use the asterisk, 2.1, asterisk, and then 10 caret -4. Okay, and then so when you have this scientific notation with a negative exponent, it means it's a very small number with a bunch of zeros in the front. So the negative exponent is indicating a very small number, not a negative number. To mention about scientific notation is that the coefficient and the exponent are inversely related. So inversely related means that if the coefficient goes up, then the exponent goes down. Or if the coefficient goes down, then the exponent goes up. And it is important to remember in the negative exponents, use a number line because it gets really confusing for the negative exponents that increase going closer to 0, meaning a number from -2 to -1 is increasing, -2 to -1, whereas normally you might say, wait a second, that's 2 to 1, but it's -2 to -1 because it's getting closer to 0. So that's an increasing. So in this example, 220 times 10 squared. To put this into scientific notation, this needs to be a number that is more than 1 but less than 10. 20 is more than 10. So this needs to take the 20, add a decimal, and move it over so that this is now 2.0. Okay, so 2.0 means that this 20 went to 2.0. So this got smaller. So that means the exponent needs to get bigger. So this is going to be from 2 up to 3. Okay, so and this is equal to the 20 times 10 squared. In this other example, let's put this number into scientific notation. This is 0.2 times 10 squared. So this is, again, not, it needs to be more than 1, less than 10. So take this decimal and move it over, and you're going to end up with 2. And this from 0.2 to 2 got bigger. So the exponent needs to get smaller. So this is bigger by a power of 10, so this needs to get smaller, or by 1 power of 10, so that's 10 to the 1. So let's look at a couple of these, and in putting these into scientific notation when you are dealing with the negative exponent. So this is 0.2. Again, this needs to be more than 1, so move the decimal over, going to be 2. So this went from 0.2 to 2, so that's bigger. So the exponent needs to get smaller, and smaller means going further from 0, 10 to the -3. So for this one, the scientific notation. For 20, 20 is add a decimal and move it over so that this is going to be 2.0. So this is 2.0, and from 20 to 2.0 is smaller. And so the exponent needs to get bigger, and bigger means getting closer to 0, which is going to be 10 to the minus 1.